Hello and welcome to Europe's spaceport here in Kourou, French Guyana, for live coverage of this Ariane 511 launch. Ariane will be taking up European satellite ENVISAT. Providing the French commentary tonight are Valérie Hortel and technical expert Laurent Jourdain. Commentating the launch in English are Henry Samuel and technical expert Jean-Michel Dezobo. You can also watch it live on the internet at arianespace.com. But first, let's have a look at what's coming up in this launch broadcast.
Tonight, we'll be providing all the information on this Ariane 5 launcher, finding out about its precise mission and the team behind the scenes.
We'll be looking in detail at the ENVISAT Earth observation satellite, finding out about its multiple roles in measuring the planet's environment, and we'll be meeting the teams involved in its construction.
And of course, we'll be with you live throughout this broadcast, taking you to the launch pad, the Jupiter control room, and we'll be there from liftoff right up until spacecraft separation. Hello and welcome from me, Henry Samuel.
And from me, Jean-Michel Dezobo.
Welcome to this 11th launch of Ariane 5, which, as you can see there, is ready on the pad. A special mention to those of you in European Space Agency centres, our guests in Madrid, Sydney, Washington, and everyone on the internet for this momentous launch of the ENVISAT polar platform. Well, we are some 15 kilometers away from the launcher, in fact, in the Jupiter control room that you can see right there.
Yes, we are just above the guy you can see on the screen and who are in charge of the central coordination of the launch campaign and of that countdown.
So what are they up to right now?
Well, of course, what you see here is just the small tip of a large pyramid of people involved in the launch everywhere in French Guiana, but also all over the world.
Well, of course, as you say, it's a huge team effort. Let's find out more about the launch campaign.
The campaign V145 to launch Ariane 511 started by the placing of the large cryogenic core stage, called EPC. Then we mated to the core stage the two solid propellant strap-on boosters, called EAP. Then we continued with the mating of the vehicle equipment bay, the VEB, and later with the arrival of the storable propellant stage, the EPS, which arrived in Guyana on the 4th of February, and which exceptionally was stacked onto the composite in the final assembly building. We are now ready to receive the spacecraft, ENVISAT, which until now followed its own campaign. And on these pictures, you can see the satellite ENVISAT traveling yesterday to the final assembly building. Today, it's being hoisted on top of the launcher vehicle. After that, it's the fairing's turn to be placed on top. We will then be ready in launch configuration. Another important event takes place on D-1, when the launcher vehicle is rolled out to the launch zone. Once the launcher is in place on D-1 in the evening in the launch zone, we will be ready to start countdown for D0. For this satellite, there is no launch window. Liftoff must take place at a precise instant. Obviously, we'll have to do our very best to successfully meet this challenge. More than ever, we will fit in a few hold margins here and there, on D-1 and D0, in order to avoid running out of time before the precise launch instant.
Well, as you can see there on the screen, the status panels are all green, which means that at the moment we have no technical problems, Jean-Michel.
Yes, like everywhere, greens means go, its status report represents one of the different systems that needs to be okay for tonight launch. And of course, the most important to be watched are the status of the ENVISAT satellite. We see here Mr. Louet, and the launcher, but also the weather. In fact, right now, a final weather check is being run, and we'll know in a few moments the result of these tests.
So, of course, all these people here are to see the accomplishment of over 10 years of work to get this ENVISAT satellite ready. And the final leg of those preparations took place here in Kourou, in the brand new S5 facility. Well, it's time now to find out in a little bit more detail about the satellite launch campaign.
The ENVISAT preparation campaign was a rather lengthy one, even a very long one in comparison with the usual communications satellite campaign. The spacecraft is a highly sophisticated one with many instruments on board of diverse nature. The campaign was long, but it also took many, many years to develop this complex spacecraft. It took 10 years in all to ready the numerous instruments which will be used to measure ocean temperatures, the composition of the atmosphere, the ozone layer. These instruments were specifically developed for the mission and prepared on-site since several months. The first instruments arrived here last March, where they were first stored until the spacecraft campaign started with its arrival at the beginning of May and lasted until mid-July. Then in October, the instruments underwent a maintenance campaign. ENVISAT is extremely complex, and the final phase of the campaign, which is running at present, started on the 3rd of January and is due to end on February 28th with the launch. A few words about the facilities we are in at present. They were developed and built for Ariane 5 passengers, but can also be used for all spacecraft to be launched with the Ariane launcher family. These facilities benefited from the long experience acquired over many years of launching and preparing spacecraft for launches with Ariane.
Dans toute la carrière d'Ariane, je dirais, et dans les diverses installations qu'on avait à notre disposition jusqu'à maintenant.
The upcoming launch is specific in several aspects. As it is an Earth observation satellite, the launch will loft it northward into a sun-synchronous orbit, which means the spacecraft always passes over the same area at the same hour of the day to compare data and imagery. T0 must be at a precise instant for phasing in with other Earth observation satellites already in orbit, in particular ERS, whose mission is to complement ENVISAT.
Well, roughly 2 minutes ago, we received the results of the final weather check, T-10, and I'm happy to say that they were good. And that is a real relief, Jean-Michel, because tonight there are more weather parameters than usual.
Yes, indeed. In addition to the usual wind and lightning risk, we have to check for this launch the level of solar winds and particle streams coming from the sun. If they are too strong, they could create unwanted perturbation to the launcher electronics when it leaves the atmosphere. Here we see the mission director, Bernard Pugrenier, and the range operation manager, Philippe Gilson, who are getting ready to announce the synchronized sequence.
Yes, that'll be coming in just a moment, the final countdown.
À tous de DDO, attention pour le début de la séquence synchronisée. Top, H0 moins 7 minutes.
There we are. Philippe Gilson has just announced the start of the synchronized sequence. And during these last 7 minutes, a whole series of final procedures and checks will be carried out by 2 computers. And they presumably have got a lot of work to do, Jean-Michel.
Oh yes, of course. They are putting the launch vehicle into its final flight configuration, both for fluids and electrical systems. In fact, now power and decision-making are being transferred to the launcher from these computers.
And, of course, all these last-minute operations are being conducted from the launcher control room, also known as the bunker, which is situated just 2 kilometers from the launch pad. And in charge there is Jean Rebeu, who will be having a busy time right now, I suppose.
Yes, Jean and his team are now actively checking everything which is happening through this computer, and they are making sure that all the sequences are being executed correctly with the good expected results.
Well, now it's time to look at a few vital statistics of the spacecraft and its launcher. This Ariane 5 weighs 750 tons and stands 50 meters tall, with a 17-meter-long fairing specially designed to house its large ENVISAT payload. Ariane 511 will place its Earth observation satellite into polar orbit, some 800 kilometers above the Earth. The launcher has 3 stages, 2 solid strap-on boosters to provide most of the thrust, a second cryotechnical stage, and a third EPS stage will place the satellite into sun-synchronous orbit. Tonight's launch is exceptional as it is the first Ariane 5 to be launched towards the north, and at 8.2 tons, its passenger ENVISAT is the biggest satellite ever launched by Ariane. Well, as we just heard, tonight's launch is exceptional in more ways than one, Jean-Michel.
Yes, you've heard that it was the first time Ariane was heading north. Ariane 5 was heading north, but also the first time it will use its super long 17 meters fairing due to the extra large size of ENVISAT.
Well, we're going to now find out just a little bit more about why it is indeed heading north this evening. For geostationary orbits, Ariane heads east. But for this ENVISAT mission, the spacecraft heads north to be in low orbit, just 800 kilometers above us. From there, it can cover the whole of the planet's surface and record changes to it as it passes over exactly the same locations every 3 days and always crosses the equator at precisely 10 a.m. local time. For this reason, the orbit is known as sun-synchronous. Every 35 days, ENVISAT generates a complete picture of the Earth's surface. Its secondary role is to further and enhance the mission of its sister satellites, ERS-1 and 2, on exactly the same orbit. Well, as we can see, their status panel's still green. And if you didn't catch what was said in the earlier satellite film, the launcher must take off at a precise moment tonight because it has to enter immediately into a specific flight plane when that plane passes over Kourou. And if it misses this rendezvous, the flight will automatically be postponed until the following day. Now, we mentioned earlier that going north means the launcher and payload are exposed to solar winds, particle streams and cosmic rays. All that sounds quite poetic, Michel.
Yes, but in fact it's not quite poetic because usually we are protected from these effects by the magnetic field of the Earth, but as you may know, the magnetic field is weaker on North and South Pole, so when you fly there, you have to be very careful. And here we have the pictures of the launcher being transferred from the final assembly building to its launch site. Just as you see, one lorry was useful to bring all that weight to the pad, and it's quite heavy weight. It's 1,500 ton on train wheels.
Just one lorry taking all of that.
And during the transfer, the launch vehicle and the payload are controlled and monitored and ventilated through a support unit, which looks like a little train behind the launch table. And once they have arrived on the launch pad, they have been reconnected to the ground links, checked, and everything was then ready for the final countdown phase, consisting mainly to fill the main cryotechnic stage.
Well, there's calm concentration in the control room. Everything is quiet on the pad. Let me just say that this launch is the culmination of, as I said, over 10 years of work by hundreds of industries. Thousands of people are involved. It's a story of European cooperation that will change the way that we see our environment from the skies.
And now, in a moment, the range operation manager will announce the final minute countdown.
À tous de DDO, attention pour moins 1 minute. Top, H0 moins 1 minute.
We're into the last minute. Welcome to any latecomers. Do keep your eyes on the screens. Our best wishes go to ESA and everyone here in the Arianespace team. The very best of luck for the launch of Ariane Flight 145.
Now we'll leave you to enjoy this liftoff, and we'll be back with you once the launcher is in flight. So Henry just ran away to see that directly.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage du Vulcain. Allumage des EAP, décollage.
So, Henry, you just ran outside to see the launch with your own eyes. How was that?
Well, actually, I've still got in my retina the light from the boosters, because it's incredible, practically daylight out there. And the rocket up went very fast, and we're just getting the rumble right now. It's quite impressive.
Yeah, it took more than 1 minute to come here.
So it took more than 1 minute. But those long shafts of light, they're coming from the solid strap-on boosters.
Oh, yeah, absolutely. These strap-on boosters provide 90% of the launcher thrust, and they are very visible. They burn 4 tons of propellant each second, and the thrust they deliver with the Vulcan is 1,200 tons, which is equivalent to, what, 12 Boeing 747 at full thrust for takeoff.
Well, it certainly looked impressive in the flesh, I can say. Now, we're still getting a very good picture of it there.
Oh yeah, this is probably using the Devil's Island telescope, infrared telescope. Or is it visual? It might be visual.
Well, I can say it's...
Anyway, we are already... What?
We've just...
Largage des étages d'accélération à poudre.
And there we've just heard that we've already had booster burnout and separation right on time. And
you see the picture on your screen.
Yeah, we
with
can see
the Vulcan still active, and on the side the 2 strap-on having been separated. We are at 95 kilometer altitude and 2 kilometers per second already at that time.
I see, and so we're now onto the main cryotechnical stage. And we're a lot lighter than we were.
Oh, yes, indeed. At liftoff, the Ariane was weighing 755 tons, and now it's only 150. And the solid strap-on booster will come and splash down in the Atlantic 500 kilometers from here.
So we're onto the main cryotechnical stage, which uses very cold liquid hydrogen and oxygen. And as we've just heard there, the protective fairing that's at the nose of the launcher, which we can see here in the simulation, has now been jettisoned as well. So the satellite is now at the helm of the ship, so to speak. And as we just heard, all the parameters are nominal or normal. So why do we get rid of the fairing now?
Well, quite simply because we don't need it anymore. The fairing was protecting the spacecraft from overheating due to friction of the Earth's atmosphere. And this friction reached its high point at T0 plus 70 seconds, what we call the maximum dynamic pressure. But as we now have left the atmosphere, there is no friction, so we can let the fairing go to keep optimizing the launcher's mass profile.
Well, we've just seen local representatives of the CNES Arianespace Center.
And of the ESA.
Yes, ESA, which has worked very hard in many ways for tonight's launch, from preparing the launcher programs to delivering and checking ENVISAT. ENVISAT, Europe's eyes in space, will be trying to answer some of the big environmental questions on global warming, the ozone, El Nino. So let's find a little bit more about that satellite.
The unique range of instruments on board ENVISAT will continuously monitor 4 key Earth areas: ice, land, atmosphere and oceans. Analysing our oceans will reveal data on sea surface topography and wave characteristics, enabling accurate weather forecasting, better knowledge of ocean currents and the sea floor. ENVISAT will also measure sea level and temperature and facilitate large-scale ocean mapping. Monitoring the polar ice caps will provide data on snow cover and ice sheet extent, together with surface topography, supporting research on climate change and global warming. Watching the land, instruments will study the dynamics of the Earth's crust and interior. Monitoring global vegetation and land use will help to determine the long-term effects of human activity. Studying the atmosphere will yield a better understanding of atmospheric chemistry and our global climate. It will increase our knowledge of ozone concentrations and the effects of aerosols, trace gases and toxic compounds, key to atmospheric pollution. Global challenges demand global solutions. ENVISAT's advanced combination of remote sensing instruments will provide exciting opportunities in environmental monitoring, putting Europe at the forefront of Earth observation over the next decade.
Okay, here we can see Mr. José Achache from ESA, and near Patrick Loire, the mission, the program director for ENVISAT. And here Bernard Pugrenier, the Arianespace mission director, keeping an eye on the launch vehicle behavior. And we hear regularly the report of our people up there at the Montagne des Pères, checking the parameters, indicating that everything is proceeding normally. We see the altitude has quite increased. We are 230 kilometer altitude, and the speed is approaching 4 kilometers per second now.
So right now we're in the cryotechnical stage, which is about halfway through its flight.
Yes, we have well progressed into the flight, and if the thrust is only 110 tons compared to the 1,200 we had at liftoff, the mass to be pushed is also much, much smaller.
The instruments on board ENVISAT will advance scientific research in regional monitoring on issues that impact directly on people's lives at local level. The availability of high-resolution, near real-time data is essential for effective disaster and resource management. Forecasting and analysis of man-made and natural hazards is vital for civil protection. ENVISAT data will be used extensively for the control of floods, forest fires and oil spillage. Risk assessment linked to storms, earthquakes and volcanic activity will also enable scientists to develop computer simulations to aid prediction and minimize risk to human life. In the management of natural resources, coastal monitoring will allow the study of water composition, looking particularly at plankton bloom and pollution. It will examine the effect of ballast water exchange on the natural ecosystem. On land, regional vegetation monitoring is helping to build an accurate picture of seasonal growth patterns and crop types linked to farming subsidies. The datasets will also directly benefit commercial activities, including the oil and gas and maritime industries. The power to focus ENVISAT's global monitoring capabilities on the regions provides a major step forward for Europe in terms of its ability to manage both resources and the security of its people.
Back in the Jupiter control room, and if you look at the curve there, which in fact indicates the planned flight path, there is something written SEP EPC. That's the burnout and separation of this main stage, which is about to occur. So where are we now in the flight, Jean-Michel?
We are right on the mark, and we are right now overflying the Northern Atlantic at an altitude of 333 kilometers and a speed approaching the 7 kilometers per second.
So the rocket actually knows when to shut down this stage?
Yes, absolutely. It has in its memory a pre-programmed flight plan, and it compares that to the real measurement it does on board, and when it matches, it just gives the shut-off command and separation.
And I'm happy to say that it's just done that. We just had separation. We just heard that from the Range Operations Manager. Separation of EPC has occurred. And what happens now to that burnt-out cryogenic stage now that its job is over?
Well, its job is not quite over. The first automatic operation is to open pyrotechnic valve and to disperse all the remaining propellant through vents. And that will make the stage tumble, and it will splash down north of Canada in the Arctic Ocean.
So watch out, all you polar bears, for any unidentified flying objects?
Well, actually, polar bears have nothing to fear. Remember, we were already at more than 300 kilometers altitude and climbing. So due to its momentum, the stage will continue to climb and then dive back down and simply burn up when re-entering the dense layers of the atmosphere at roughly an altitude of 60 kilometers. And there will be nearly nothing left of it by roughly 20 kilometers.
Well, that's a relief for an environmental satellite. Now it's time to look at the countries and people throughout Europe that made this challenging venture possible. ENVISAT is the largest, most sophisticated Earth observation satellite ever, and is a major achievement for European industry and technology. After a decade of development, ENVISAT will provide new and enhanced observation that will complement the ERS satellite series. 120 mainly European industries have risen to the ENVISAT challenge that some said was impossible to achieve. This world-leading program is being carried out for ESA by a consortium led by Astrium. ENVISAT has required breakthroughs in the optical domain, such as new technologies for high-precision spectrometers and calibration. There have been innovations too in advanced radar techniques, active antenna, and transmit and receive modules. An equally demanding task has been to develop ground support systems. Satellite control is handled by ESOG in Darmstadt, Germany. ENVISAT sends its data to Kiruna, Sweden and Frascati, Italy, directly or via the Artemis data relay satellite. Here the information is processed, archived and distributed to the end user, with the capacity to do so almost in real time. ENVISAT's wide range of instruments and innovative ground systems has put Europe at the forefront of Earth observation. It also fulfills many of the needs of GMES, the European Initiative for Global Monitoring for Environment and Security, by providing users more detailed and accurate data than ever before.
Yes, you have heard ENVISAT is part of the Global Monitoring for Environment and Security project within Europe. And there is also another very large project within Europe which is going on, named the Galileo Constellation Project. By the way, during the film, we heard and we saw here the DDO announced that the next tracking station has acquired the launch vehicle Signal. The station, owned by NASA, is located near our friends in Washington. It's located in Maryland, on the island of Wallops.
We don't often hear so much from that station, Jean-Michel, but presumably that's because we don't often go north.
Yes, indeed. We are used to the westward station like Natal, Ascension, Libreville and Malindi in Africa. But here, flying, heading north, we will use Wallops and Saint Hubert in Canada, Svalbard and Fairbanks on the way down for PPF and ENVISAT.
So Wallops we have now, and next one will be?
Svalbard.
Well, Ariane, of course, is not, as many people believe, a French rocket. It is a truly European endeavour and part of a far-reaching vision of independent access to space for Europe. So,
we receive a good report of the EPS functioning in flight.
Let's find out about that European endeavour.
Through the European Space Agency, European countries have entrusted Arianespace with running the Ariane launch system and associated facilities, a mission which Arianespace has honored for the past 21 years. Arianespace has several roles. Firstly, to lead the production of the launch vehicle, to prepare and to operate it in French Guiana, and of course, to sell it. Arianespace makes sure that the industrial returns throughout Europe are in line with individual member countries' investment in the program. Arianespace guarantees independent access to space, enabling European states to launch strategic and scientific satellites whenever they see fit. Over 21 years' experience in commercial operations of Ariane have led all the companies involved in the program to greatly improve their performance. Launch after launch, Ariane is improved, upgraded and optimized thanks to the know-how of its industrial partners. A good example are the upcoming upgrades to Ariane 5. After 6 years in operation for Ariane 5, the new Ariane Plus model will take to the skies in a few months. This launcher offers enhanced performance to meet market needs. Looking forward, Arianespace fully intends to stay ahead of the competition and to remain the focal point of the European space industry.
Well, we're already 7 minutes into the flight of the EPS storable propellant stage, which we haven't really discussed yet, but that is actually going to deliver the spacecraft into its final orbit.
Yes, the EPS is the upper stage of the rockets, and even if its thrust is small, it will burn very long, and it will be the one necessary to bring the spacecraft to its final orbit. You see, we still have some altitude to gain and some speed to gain, and this will be the role of the EPS, and this one is functioning right now exactly according to the plan.
Now, I heard that there have been quite a few improvements made to that EPS stage since the last Ariane flight.
Since the last Ariane 5 flight, a lot of work has been done on this one. First, the people have found that the design of the engine was absolutely sound, and but some improvement needed to be done on the way to implement it. So a lot of testing took place mostly in Germany at the DLR, and they did more than 300 tests, ignition tests mostly, and these tests led to precisely adjust the ignition sequence and the way to operate the EPS engine.
This is only one step in a long path, of course, towards getting the next Ariane 5 Plus up and running.
You see here behind me the Ariane 5 launch table number 2, which has been recently outfitted to perform a tanking exercise with the help of this MR mock-up, the purpose of which is to qualify all procedures and methods to be used to prepare and launch the new Ariane 5 upper stage of the future. Here we are on one of the higher platforms. Behind me, the cryogenic upper stage called ECA, which will equip Ariane 5 in the future to obtain a performance of 10 tons in geostationary transfer orbit. This stage is integrated by Astrium and uses the HM7B engine built by SNECMA. It has already been prepared here, and we will now go to have a closer look at this platform. Here the interface that will allow for liquid hydrogen tanking of the stage. And here the cryogenic arm that supports the umbilical interface in its correct position until it is released a few seconds before ignition. On the other side, the interface is slightly more complicated. It provides for liquid oxygen tanking as well as for helium pressurization. Here you see the liquid oxygen arm, which is installed on the launch table, and here the newly added attachment system, which was placed on the Ariane launch table. On the other side, symmetrically, the other cryogenic arm attachment. Both were installed during the recent months, and the whole system was validated. Here we are in the launch zone. The launch tower that stands behind the launch table during the Ariane 5 launch has also been newly outfitted to accommodate the new fixtures needed for the final preparation and fueling of the new ECA stage. Thus, in mid-2002, we will be able to provide our customers with a performance of 10 tons to satisfy the market requirements. Concurrently, since last year, we inaugurated the new payload preparation complex, the S5 building, to provide our customers and the entire space community with coherent service in a highly competitive market. Thus, with the help of these innovative tools, Arianespace is able to serve its international customers.
Back to Jupiter. How is the launcher doing in terms of velocity, Jean-Michel?
Yeah, as you see on the curve, we are approaching the final altitude, and for the viewers used to the geotransfer launchers, they may have noticed a big difference in the speed, because usually for the geotransfer launches we are separating the spacecraft at a speed of 9 and so kilometers per second. Here we are on a very different type of orbit, and the target is much lower. It's 7.5 kilometers per second.
Now, coming back to the Ariane 5, as well as the improvements on the ground that we just saw, the rocket itself will be receiving a new upper stage.
Yes, this new stage will boost its capacity to geotransfer orbit from 6 to 10 tons, and will change the present upper stage by a cryotechnic one.
Well, let's just see what this new Ariane 10 tons has in store for us.
Tous les paramètres bord.
Here we are on the roof of the CAS tower, which has just undergone a whole set of modifications. The tower stands next to the ELA launch pad from where Ariane 5 will lift off, and we upgraded this CAS tower to adapt it to the new Ariane 5 model with a 10-ton capacity, which will arrive this summer. Why did we make these changes? Because Ariane 5 10 tons is made up of the classic Ariane 5 and an upper cryogenic stage, the same one used in Ariane 4's third stage, which has successfully flown 130 times. There'll also be a specific Ariane 5 stage. The cryogenic stage will give Ariane 5 a geostationary transfer capability of 10 tons. As well as the work on the CAS tower, we have an important program with a fueling mock-up called the MR. And this mock-up will allow us to validate here that all the equipment works perfectly before liftoff. Right now, this mock-up is in the launcher integration building over there. And now that ENVISAT has left for the final assembly building, the fueling mock-up will take its place before coming here. Until May, we'll be testing all the fueling systems. Once that's done, Ariane 5 10 tons will be transferred here to Kourou in the summer for its maiden flight. Ariane 5 already has a 6-year lead over its American competitors, and thanks to Ariane 5 10 tons, we'll strengthen that lead, as we'll be the only space transport company capable of taking 10 tons into geostationary transfer orbit. So do join us this summer for that maiden flight.
Fin de visibilité par la station de Wallops.
Well, Could you translate what you just said there,
Yeah,
Jean-Michel?
the range operation manager just announced that the Wallops station has the loss of signal, and we will have a little moment before Svalbard get the signal. So during that time,
that was quite normal.
It was quite quick. So it got the signal below the horizon, in fact. So it's much better than the gap we were sort of expecting, and in fact we didn't have a gap.
So now the launcher is being tracked by Svalbard, which is where?
It's on the Norwegian island of Spitsberg in the North Sea.
So tracking stations are not just important for checking the flight path, they have several other roles.
Oh, yes, indeed. This telemetry is not used only to know where the launch vehicle is, but above all to monitor the precise behavior of the launcher. And we do this in two ways. First, in real time, we extract the most important parameters, such as engine functioning, stage status, etc., to give those in charge of flight safety a good idea of their condition. And after that, all the data this time is extensively reviewed by our people in the industry to check in detail that everything went as planned. And this allows the authorization of the next flight.
So we're now approaching extinction, and that was it, extinction of the EPS stage, which will be followed, in about 2 minutes by spacecraft separation?
Yes, and we are right on the mark because the target altitude and target speed are exactly those you can read on the screen, so it looks like a perfect bullseye.
Well, talk us exactly through what will be happening during these final moments leading up to separation.
Yeah, because before releasing the spacecraft, we have to ensure its correct orientation in space. And this leads to an orientation phase, which is being run right now. The onboard computer uses its inertial guidance reference to place the spacecraft main axis at the exact location required by the customer through a set of 3D maneuvers in space.
So why doesn't the satellite carry out this task of fine-tuning its orbit itself?
Well, the satellite could do it, but using the launch vehicle to perform this saves time and fuel, prolonging the spacecraft lifespan. And it also, of course, simplifies the early operations for the spacecraft team, which have a lot to do already.
So when the actual separation occurs, how does that separation occur?
Well, we have what we call a clamp band, linking the spacecraft to its adapter on the EPS and the vehicle equipment bay. And that clamp band is pyrotechnically cut, and we have springs pushing the satellite and the EPS away from one and the other. And here we are.
Wow! This is the moment we've been waiting for. Marvelous. ENVISAT, as you probably gathered, is now separated from the final EPS stage. Celebration and satisfaction here, a huge success both for Ariane 5 and this phenomenal ENVISAT payload that may well change the way that not just individuals but governments look at the environment, providing objective, irrefutable proof of climate changes and pollution and ozone levels.
Yes, Arianespace's work is nearly over, but for the spacecraft personnel, it is just beginning, and they will not breathe easily until they, well, how they say, they hear the baby cry when they receive the first signal from the satellite in the right position. And we'll know when that happens when our colleagues in Darmstadt ring us to confirm that some minutes after separation.
We're going to have a look now again at that marvelous launch.
And we see Mr. Jean-Marie Litton congratulating Mr. Ashash here in Jupiter, and
here's the launch again, as I just promised you.
Allumage des EAP, décollage.
impressive stuff. So you said that Ariane's work is nearly over, but what else is there to do right now?
Well, since the launch vehicle is on the exact same orbit as ENVISAT, we have to perform an avoidance maneuver to be sure that the final stage and the satellite never meet again in space. And plus, to avoid Earth orbit pollution by space debris, once this operation is performed, we totally empty all remaining propellant and gases from the EPS tanks and also from the VEB control system tanks.
And how do we do that? Through vents?
We open vents and out gas in space.
So we have the impression there that everyone has stopped working, but that's not in fact the case. In fact, Chairman and CEO Mr. Luton still has some important information to gather.
Yeah, that's right, Henry. They are gathering through the people checking the telemetry, the exact, what we call the first diagnosis of the satellite parameters. And we'll know, well, we have from the direct report.
Looks like we're having another look at that liftoff.
Yeah, well, together we had a direct control from the telemetry on the screen that the mark seems excellent, but now we have to have the refined telemetry exploitation to have the last digit after after the comma to make sure that it is not only very good but also excellent.
As I say, so we know it was a success, but we need a sort of second opinion just to check everything in more detail. Well, in a moment we will be having some speeches, but perhaps time again to say that this has been a very important launch for Ariane 5 and is actually key for its future, and is a great stepping stone for the Ariane 5 Plus that will be coming up this
yes,
summer.
Absolutely, and not only for Ariane 5 Plus, but also to demonstrate that the Ariane 5 is able to carry to orbit a very heavy payload. So this one was 8.2 tons, and we have already in the books a still heavier one, our automated transfer vehicle, the ATV, aiming at the space station. And in 2 years from now, a little bit more than 2 years from now, we will have an even bigger record-breaking payload for Ariane 5. And that launch tonight was important to prove to ESA, who will be again the customer for ATV, that Ariane 5 knows to do well how to do its job.
And of course, coming up in these new stages, in the new Ariane 5, as we said, is this new cryotechnical stage that is exactly like the old, like the former Ariane 4.
Well, it's derived. A lot of elements are exactly the same, but some other have to be adapted, because you see the just an example, the diameter of the Ariane 5 is much wider than the Ariane 4. So you have to make new tanks for the hydrogen, for instance, for the ECA. But you can reuse a lot of bits and pieces coming from Ariane 4.
It looks like the chairman and CEO, Mr. Luton, is about to speak.
Mesdames, Messieurs,
ladies and gentlemen, dear friends,
bravo l'Europe.
Bravo, Europe. Congratulations.
Voilà ce qui me vient à l'esprit.
That's the first idea that comes to my mind, and that's what I intend to say to you at this very moment, where we are sharing the wonderful success of the ENVISAT launch. Bravo, because over and beyond the launch of this extraordinary spacecraft, it's the success of European space in its entirety that we can celebrate here this evening, here in Kourou, but also at ESOC in Germany, at the sites of the European Space Agency in Frascati, at ESTEC, at Villafranca, in Spain, but also in Évry, Toulouse, Washington, and Tokyo. First of all, It appears to me that ENVISAT in itself is a very strong symbol for the role that Europe united can play in this world. First of all, it's a European instrument, the fruit of a European policy. It is also at the service of environmental concerns of a planetary dimension. And I believe that that's there that we find the justification for the programs of the European Space Agency. We must provide Europe with the instruments that allow Europe to play a role at world scale. And in this context, ENVISAT responds very well to the ambition that the member states of the Space Agency have. On the scientific industrial side, it's a technical success as well as a success of cooperation, which all European industries have played together. I would therefore like to address my congratulations to Astrium as well as to all the 50 European companies who, under Astrium's leadership, built the largest satellite ever built on our continent. But the success of European space is also the success of a launcher called Ariane here in Guyana particularly. Dear friends, I'm extremely happy to be able to share with you tonight this successful launch. Everybody noted that in the course of this evening, everybody was quite tense and even stressed because this launch was a very important launch. We all know that the 11th flight of Ariane 5 is also the first return to flight of a launcher which had a problem at its last launch, V145. With the orbiting of ENVISAT Ariane 5 is back again on track and perfectly operational. It is therefore with satisfaction and relief that we put an end to the interval between launchings within our activity and with our job. What differentiates us from others in stressful moments is trusting on our know-how and also motivated by a particular determination to understand and thus attain excellence. It is also a symbol of the human wealth available to us in Europe and it alone that allows us to celebrate this success this evening. Therefore, I'd like to pay a particular tribute to all those who allowed for this success, to the Inquiry Board, to Astrium, EADS, CNES, DLR, ESA, Arianespace, and all those who worked without sparing any effort since the Flight 142 to bring our spacecraft back on track. I'm sure you understood the meaningful sense that this launching has this evening. It's a symbol for the level of excellence reached by the European industry, not only for launches but also for spacecraft. We must assemble efforts. It shows also what European space is able to do when it is united around a common policy, and that is why I'd like to repeat, bravo for Europe. Thank you all. Thank you all, and I'd like to point out that the next launch is foreseen with an Ariane 4 in the second half of March.
Thank you, Mr. Luton. Thank you very much. It was quite a day. It was quite a launch. I've been attending several launches here, but it's never been like this before, at least for me. As Jean-Marie Luton stated it very precisely, it's a major event for ESA, it's a major event for Arianespace. For both of us, ESA and Arianespace, having Ariane 5 back in full operational condition is great news. It's the launcher of Europe, it's the launcher of ESA, so it's a good news for us as well. So let me first congratulate Arianespace and congratulate all the teams, ESA teams, CNES, GLA teams, who have been working like hell over the last 3 months to make sure that this launch would take place today, and this date was decided very strongly and was held until the end. So I want really to express my congratulations for having achieved that in time and so perfectly. Let me talk a little bit about ENVISAT. It's the beginning of its life, flying life. So today it's the accomplishment of 10 years of efforts by engineers within ESA, engineers in the European industry, the scientific community, and it's the very important date, but it's only the beginning of many things. I've heard all sorts of comments about ENVISAT, and I've read all sorts of comments that it's big, it's the largest, it's heavy, it's expensive, it's a truck, it's a lorry. I would here say that for me, this is the most sophisticated, this is the most innovative laboratory ever put in space to study the Earth and to monitor the environment. And that's what I want to think about with ENVISAT. So ENVISAT will provide us the continuity of measurements that were started with ERS in 1992, but it will give us a much larger capability, have a much larger mission, in particular start measurements, very extensive measurements of the chemistry of the atmosphere. And it's going to be wonderful for the scientific community. But ENVISAT is not just for science. ENVISAT will be at the forefront of environmental studies and environmental applications. I would like to think of ENVISAT as our cornerstone for the Living Planet program of ESA, in which our intention is to serve the citizen with good science, with good services, with monitoring of the environment. And we will do that in partnership with the European Union in the framework of the Global Monitoring for Environment and Security program, which clearly got its go-ahead tonight with the launch of this satellite. But as I said, we had a beautiful, successful launch, but things are not over yet for the satellite. The life of this satellite is like natural environmental processes. They have several embedded timescales. So in the short future, we will have to wait another 50 minutes until we've deployed the solar array. That will be 59 minutes after launch, after H0, and then wait until we've acquired the full stabilization, which will be 70 minutes after H0. So this is the first important timescale to which we are looking now. And indeed, we will have on the screens here an interesting animation where software will simulate in 3 dimensions the operations that are taking place based on the telemetry that is received down in ESA, which is transmitted to here, and which will be used to drive an animation which will show you how the satellite will continue its life until full deployment of the solar array. Then there will be more operation in the coming days, the deployment of the ASR, the deployment of the antennas, and eventually the complete deployment of the satellites. That will be another number of days. And then the next step will be the calibration and validation of all these instruments in flight. For some of them, the simplest one, it will take 3 to 4 months. For the most complicated and innovative ones, it will go to six to 9 months. Then all these instruments will be declared fully operational. The data will start flowing to the scientific community. And then we're looking at the last time scale, which is of major interest for me. It's the 5 years of life and operations and the 5, 10, 15, 20 years of exploitation of the data. So I definitely look forward to this period, all these periods. So let me just allow me to just thank all the teams who've been working for this satellite. I'd like to thank Astrium and Alcatel, as well as all the industries that have been working to build this satellite. And of course, I'd like to express a big thank to all ESA's teams at ESTEC, at ESOC, at ESRIN, who are currently watching us and who have been working wonderfully to build this satellite and to make this undertaking a big success. And also, please allow me to express my congratulations to my predecessor, Claudio Mastracci, who in fact bears more responsibility for these programs than I actually do. Thank you very much. Merci.
So thank you to you all for tuning in this launch broadcast. Thank you, Henry, for an excellent teamwork for this very special launch tonight.
Don't mention it. And thank you, Jean-Michel, for all of your insights. I couldn't have done it without you. And I imagine that celebrations will be continuing into the night. It's been a pleasure working with you, Jean-Michel, and all of you watching from around the world who played a part in this mission. Congratulations. We look forward to seeing the results from ENVISAT's observations, of course. And we also look forward to working with you again soon here at Arianespace.
And we can say see you next for the next Ariane 4 launch, which has been announced in the second half of March by Mr. Luton. Bye-bye.
Bye-bye.